I go straight to the point. As I told you last time, today's episode will be about, once again, the most important chemicals categories for ceramic glazes. Chemicals that provide the glaze with the right features to develop a proper application and to reach technical and aesthetic high performance. In the first part of this long overview, and of course I invite you to listen to the previous episode, we started with a question that was, what happened to a glaze if you do not use any kind of chemicals? And then we went on talking about chemicals for grinding, such as binders and dispersant, moving later toward the glazing line, where we addressed the so-called binder for glazes. This is the first category of chemicals involved at this stage of the ceramic production process. And today we remain along the glazing line to take a closer look at all the other chemicals that are necessary for the production steps that take place here. I am Davide Trentini and this is Apparently Invisible Chemistry in Ceramic. Okay, let's start immediately our journey by talking about leveling agents and by saying that in ceramic, as we know, the proper leveling of the glaze can be reached in many different ways. And when we talk about leveling agents, we usually and mostly refer to two different categories: surfactants on one side and wetting agents on the other side. To speak about surfactants means to speak about high-performing soluble products that, by definition, can lower the surface tension of the system and, in our case, of course, of the glaze, thanks to their molecular structure that is made of a hydrophilic head and a hydrophobic tail. I repeat it, hydrophilic head and hydrophobic tail. What does that mean and how does it work? After the surfactant has been added to the glaze suspension, this is what happened on the surface. The tail, since it is hydrophobic, remains outside the water. We could also say that the tail is exposed to the air, while the head, that is hydrophilic, and so that it's in the water, separates the molecules that are on the surface of the water by lowering the surface tension. And it is exactly this reduction of the surface tension that leads to a better application of the glaze, and especially to a better leveling. By the way, if any of you still don't know what the surface tension is, I invite you to download for free our app, in which you can find, together with all the previous episodes of the podcast, many different contents, and in particular a section called Chemistry Pills that includes a sort, we could say, of vocabulary of keywords related to chemistry and ceramic production, and where you can also find a long description about surfactants. That said, I also want to make an example to better explain you how surfactants decrease the surface tension. And that's why I invite you to think about, right now, an oil frying pan. If we try to clean it by using only water, as we perfectly know, we will not get any good result, since the water, we could say, is not able to wet the oil. What happens if we add any detergent that is and represent, in this case, our surfactants? It happens that the surface tension of the water is modified, that is, lowered, allowing the oil to be wet and so to be removed from our pan. I think it's quite clear, but let's go ahead. Since they are completely soluble and since they are used in very low dosages, surfactants do not normally produce any surface defects, such as, for example, holes or pinholes. However, they can be highly foaming and difficult to control. And so the question is, how does a surfactant produce foam? And what is the structure of a foam bubble? Foam bubbles created by surfactants are nothing more than spherical films of water molecules held together by the same surfactants. In ceramics, when the glaze suspension is under stirring inside the tank along the glazing line, the air can enter in the glaze suspension, producing foam bubbles that rise to the surface, and this happens especially when the stirring process is marked by a high speed. This ability to produce foam is the reason why surfactants are not frequently used in the ceramic production process, and they are, when possible of course, replaced by wetting agents that are more manageable. So let's give a look at these chemicals more closely. In some cases, to face or avoid the problems provoked by surfactants, as we have already said, it is possible to use, to replace them, partially hydrosoluble leveling agents that, on the one hand, do not provide the system with any anti-foam properties, but that, on the other hand, can wet the inorganic glaze particles by lowering the surface tension of the water just enough to separate the particles and so promoting their homogeneous dispersion within the system. Decrease of the water's high surface tension that normally doesn't allow the water molecules to enter, or we could say to penetrate the agglomeration, makes the water able to move between the suspended and agglomerated solid particles, leading to a de-agglomeration. And this de-agglomeration, together with the lowering of the surface tension, is exactly the responsible of the proper glaze leveling on the ceramic support. And now it's time to talk about another category, that is about defoamers, that, as the word says clearly, are chemicals very effective in preventing or eliminating air bubbles that can sometimes form and be trapped inside the glaze or on its surface. The foam, in fact, as we already stated, can appear both inside the stirring tank and after application, that is, on the glazing surface when the glaze has been already discharged on the raw tile. But how do defoamers work? The defoamer, since it is water insoluble, I repeat it, insoluble, can destabilize the foaming system by acting on the surface tension of the foam, and so by breaking the hydrophobic tails of the surfactants and therefore promoting the explosion of the bubble. To better understand, let's make, even in this case, another example from the world of cooking. Let's start beating an egg. If we do it only with the egg white, we will observe the progressive formation of foam. If instead we beat the entire egg, that is, egg white plus yolk, we will not see any foaming phenomena. Why? It's very easy. The egg yolk, that ideally is our defoamers, contains a very high amount of fats, and especially triglyceride, that exactly act as a defoamer by containing or avoiding the formation of foam. That said, let's add now a new important element that may complicate things. When added to not very plastic glazes that are marked by a low content of glaze, or to hard glazes, such as for example glazes containing only frets, the defoamer tends to be dispersed in water, sometimes causing defects such as holes or pinholes. This means that the use of defoamers to stop the foam formation promoted by the surfactants can partially or totally solve the problem, but the balance that is created can be sometimes quite unstable. On the one hand, in fact, we have a defoamer to counteract the action of the surfactants. On the other hand, we must also face the action of the defoamer that, in high dosage, can produce depressions and holes due to its water insolubility. This is the classic dog that bites its own tail, we could say. But no panic. Despite this scenario, in fact, it doesn't mean that in ceramics surfactants and defoamers cannot be used in combination. On the contrary, this happens frequently, but this combo must be carefully managed until a perfect balance is achieved with a tailored solutions. And now we end finally with this long panorama by introducing the last two categories of chemicals that can be added directly along the glazing line. We are talking about dispersant and suspending agents. Without making a list of the different scenarios, the fluidization of a glaze is particularly important when the glaze is too plastic, and therefore it is unable to correctly level on the ceramic support. The dispersant is involved precisely for deconstructing the system. Just like dispersant used in the grinding stage, they lower the viscosity of the suspension by keeping separate the solid suspended particles, and this action makes it possible to get the correct and required viscosity values according to the chosen application system, therefore allowing the proper leveling of the glaze. And what about suspending agents? Suspending agents act on possible sedimentation phenomena that may occur inside the glaze, such as, for example, in the stirring tanks. Even in this case, as their name clearly explains, their function is to keep the solid parts of the glaze in suspension within the system. But how do they do it? I try to tell you as simply as possible, even if I perfectly know that we are simplifying a very complex topic. Anyway, suspending agents can act from the steric point of view by producing a grid, or we could say by creating a space inside the system by means of specific polymers to avoid the approach of the particles and at the same time to contrast the gravitational force that would bring the solid parts to fall in the lowest part of the tank. Suspending agent can also act on the ionic charge level by increasing some ions that have the possibility to saturate the water and therefore making the system more structured. And so the overview ends here. I know that we could or should add much more information, but as you know, the challenge of this podcast is to talk about very complex subjects in a very simple way. And this is the most difficult things to do if you don't want to be trivial. That's why I really hope I gave you a general and a clear picture about the topic that of course you can deepen if you want by calling or emailing us. You can find all contacts on our website, which is ceramco.it. ceramco.it. I finally take this opportunity to remind you, as usual, that the previous episodes of the podcast are available not only on the main platform, such as Spotify, Apple, or Google Podcast, but also on our app that you can download for free on Apple Store or Google Play. You can find it by typing Z&S Ceramco. Once again, CERAMCO. And now it's time for us to say goodbye. See you soon.